Okay, just wanted to give a quick intro before we move on to Zach. So this is Erlang and Elixir Asia, a meetup. We try to do a meetup once a month. If anybody's interested in giving a lightning talk, so go ahead and scan the QR code or just reach out to me over meetup or email, etc. And feel free to present. We're trying to show, what we're doing with Elixir Erlang within Asia. So anybody who's interested to present, just let me know. We always have space. And now we have a talk with Zach Daniel. Zach is the author and creator of Ash Framework. And I'll go ahead and let you give your introduction, Zach.
Thanks for having me. Great to be here. My name's Zach. I am, as stated, the author of Ash Framework. I'm also a principal platform engineer at Alembic, which is an agency. So if you need help with anything, we're the ones to call. I think we're just going to dive right in, and I'll kind of explain the general format here, which is we're going to start with the basis of a talk that I gave at ElixirConf EU recently. And we also have sort of two things, sort of add-on modules, which are basically kind of a brief introduction to Ash and how it's shaped and how it works, and then a kind of past, present, future discussion. So I'm not going to try to give you the 10-second elevator pitch on Ash. I think I'm just going to dive into the talk, and I think it'll make itself clear in that way. So Ash Framework, it's a resource-oriented declarative design application framework. And application framework is a really important aspect of this, right? Where Phoenix is a web framework, for example, Ash is an application framework. So you can use them together, you can use them separately, but ultimately Phoenix takes a pretty strong stance that it does not decide how you build your application. Phoenix is not your app, and as risky of a thing as it might be to say, Ash is your app. That is the point of it. It is for building your application layer. So we've had a lot of community growth recently. In September, we switched over to Elixir Forum for our support channel, like our primary support channel. We still have Discord and Slack and all that sort of stuff, but we get about 10 posts a week on Elixir Forum, which I think is really nice. And Aston at the Elixir Forum actually just sort of upgraded us to get this new fancy area and to live on the sidebar, just like Phoenix and Nerves and that kind of thing. We also have a book coming. Rebecca Lee is spearheading this. And I think I've brought up this book a few times, and I have not made that as clear as I wanted to make it, that I am not the primary author on this book. So I am helping with writing, and I'm helping with a lot of the technical stuff. But Rebecca, she's an amazing writer, and we've got a large portion of it done so far. And I've recently just done a reread, and honestly, like, her writing style is amazing. I'm so excited about this book. And I think it's exactly what a lot of people have been asking for, which is not a series of guides or topical things, but really a journey that I think takes you through to a much deeper understanding of the tool. So very excited about that. So you may have heard this before. This is something I've been working on for a long time. This is the story of a function. And we're going to talk a bit about, it's a really simple concept, but about how the functions that we use to compose our applications grow over time. So this is a baby function. It's beautiful. It's very simple. It's very easy to understand, right? If you look at this, you're like, what does this function do? Okay, well, it says it's called list tweet, and it gives me all the tweets. What else could be simpler? But this is a toddler function. And I would say that this is still simple. It's just maybe we get the tweets for a specific user, or maybe we get all the tweets. However, I think this is where it kind of starts to go off the rails. This is an adolescent function. Now, I know people say, hey, put all these in other functions, but honestly, like, especially in a language like Elixir, it's still this. Even if you were to make a function called like filter by user ID and then, sort, this is still the logic that you have, even if it's broken up into a bunch of little named functions. That's really just a sort of organizational concern, not a how simple is calling this function. So this is unpleasant. It's a handful, and it talks back to its parents. And what I mean here is this function has a lot of opinions about how you're supposed to use it. Like, if you want to get stats, you're supposed to say, give, stats true. You specify a sort, and these are like named. This is like a little language that this function has. Like if you have top or latest, these are names that you have to know to call this function. Okay, now it's grown up a little bit though, right? So it's cleaned itself up. Now we have these nice names for the little operations that we apply. It's relatively easy to understand what order of operations things happen in. But I would argue that its potential has been wasted. And there are millions of functions like this out there, right? So as I've worked on at least 30 production Elixir applications, and this is what they're made of. These are the most common things that you will see that we build our sort of business logic, our application logic out of. And the truth is, this is not bad. Like, this is relatively one of the best things that I can hope to see when I go to work on an application. So I'm not trying to say like, oh, functions are gross, don't use functions, and I'm not trying to say that somehow the primitives that Elixir gives us are bad. I would love it as a consultant. If I come in and this is what I see that I need to figure out, I'm like, nice, okay, I can work with this. But we can do better. And I think that's really the position that Ash takes, is not that the options that we have right now are bad or somehow like low quality, only that we can take things even a little bit further. So I want to define terms a little bit. Imperative versus declarative is kind of an important thing, and there are various definitions floating around. There are academic definitions of the words imperative and declarative, and there are the sort of generalized, general purpose definitions that we use every day. So instead of relying on what we all think those words mean, I'm just going to tell you what I mean. And ultimately, imperative is where you might be working with code. In declarative systems, you're working with data. You might be working with instructions in imperative code, but you might be stating the end result in a declarative system. So to give you an example, we have the instructions: pick up your toys, put your laundry in the hamper, and make the bed. Or we could say, your room better be clean when I get home, or there will be hell to pay. Now, that is sort of an example of declarative, right? Where we don't tell them exactly how to clean their room. We tell them that it needs to be clean. But this is a point that's often glossed over when people talk about declarative code, which is that this only works if they know how to clean their room, right? So you can say write declarative code all day long, but declarative code is actually about working on top of smarter tools and telling these smart tools what to do. You can't just write declarative code without essentially creating some sort of delineation, some abstraction of some kind of a smart tool, and how you can tell it what goal it needs to accomplish and how it can accomplish that goal. So this is often a missing piece, I think, when people talk about declarative design. And I think it's also really important to note that imperative versus declarative is actually relative, which makes it a slightly less useful term because its definition changes over time as we start building smarter systems and as our tools get better. So this right here, these examples would have been where the discussion on declarative versus imperative was, just a few years ago. And I mean, people still talk about it in this way, right? So in this imperative mode on the left, we don't tell JavaScript. I mean, you can actually now, but for a time you couldn't. And you wouldn't say for each item in the list, do this. You would instead say start at 0, go all the way up to the length and increment a variable, and then get the thing at that index. And so you told it how to enumerate the items in a list. Versus in a declarative pattern, and this is what we do with Elixir, and this is what you also do in modern JavaScript, right? Is you say for each item in the list, however that works, right? We're going to do something. And this is actually really powerful. This is quite important because this actually unlocks entirely new capabilities, right? This enum.map is not sitting on top of only lists, right? This isn't lists.forEach or whatever. This means this list could be a stream, or it could be some other custom enumerable. And so it's a powerful pattern where when we switch to declarative, our instructions can be leveraged for more advanced operations. Here's an example. This is on the right here. This policy code is policy code that we have in Ash. But this is one way that you might do this. You might authorize access to an ecto query given some user. And you might, do some flag checks on the user, like, okay, if they're deactivated, then they can't do it. If they're a super admin, then return the query. And if they're active, then they should only see published results, right? This is really similar. Like if you know how to read this part and you know how to read that part, they look really similar. But there is a really important distinction in the way that they're built. And so to illustrate that, I'm going to show you what policies actually look like under the hood. This looks kind of like functions, but it's actually data. So we take this structure here, we turn it into this structure here, which is essentially a big Boolean statement. And then at some point it becomes this because we pass it, we don't need to understand how the solving system works for our policy logic, But the important bit is I can't go from this stuff on the left here. I can't compile it to data and then turn it into appropriate input for a Boolean satisfiability solver, which is what we use for policy logic under the hood. And you can't do that with code, but you can do that with data. It's a very fine distinction, but it's important to have. So I want to talk about imperative code and how it imposes artificial constraints. And that this happens all over the place. And once you get in your mindset of, if I had had a declarative tool to do this, I wouldn't have been dealing with this constraint that I'm dealing with. It becomes difficult to unsee. You start thinking like, if there was a smart tool that knew how to follow instructions, it could do it way better than what I have to handwrite it to do. So we're going to go over a couple of these artificial constraints. And for now, I'm just going to demonstrate the problem, and we're going to talk a little bit about solutions later. So this is a really simple one, which is order matters, right? Which this comes from essentially when you write sequential code. So here we have add some computed field, and then we have add some computed field too. And what you don't know under the hood is that there's a dependency on add some computed field too. Like it's going to compute something based on what the first field computes. So you can't just swap the two, right? Order matters. And the thing about it is, for computing properties, it is not necessarily the case that computing properties must be done in a sequential order. Like it is possible to write, and this happens if you've ever written a spreadsheet. You've seen this. You just reference a cell in the spreadsheet, and the value of that is automatically flows through to what you're doing. You don't have to say first compute this cell and then compute this cell, and then you can visit my cell and compute my result, right? So there's a solver internally that is going to figure out what order things can be computed in. And that is a design pattern you could adopt for calculations. We'll get into how we did, but in this example, we haven't. So simple or optimized, pick one. And this is a really classic thing that as engineers we deal with almost every day, which is we know it could be made slightly better in various ways, but it's not worth the complexity brought about from making it better in those ways, right? Simplicity is an extremely important axis to keep on the low end. So here's an example of a case here where we're filtering a list of tweets two different ways. We're saying, give me the ones where they're for active users and give me the ones where they're from friends of this current user. And both of these are nice little utility functions. However, they both join to the user table. And you could find a way to only join to the user table one time. And we'll talk a little bit more about how this happens, right? You want to be able to compose these functions, right? You want these functions to stand on their own. You don't want them to depend on having a user join happening some other place, that sort of thing. So that's why we designed it this way. But it is technically leaving some performance on the table. And the truth is, I think most of us would decide to leave it. Like, don't figure anything out. It's simple. What's the big deal? You're joining to the same table twice. It's probably got an index on it. It's one of our most, commonly accessed tables. Don't worry about it, right? Move on. This is where we're joining twice. But let's say this did become an issue, or let's say you did want to optimize this. What would you have to do? And I think that's an important question when you're looking at these things is, well, how would I optimize it if the need arises? This is an example of what it might look like. So in here, we have these utility functions to join to tables, but only if we haven't already joined to them, right? And this, I've seen this. This is actually a thing, which is, Ecto has this concept of named bindings, where when you join to something, you give it a name. And then you can leverage that to see, well, hey, have I already introduced this name binding? And this is a tool for optimizing these things. So now these functions still stand on their own, but they don't do unnecessary joins. It works, but if I saw somebody, make a pull request with that optimization, I'd be like, you really need to justify this complexity. Like, is it slow in real life? But the important thing is that when we do things like this, we often build in, and I'm going to show another example here, we often build in a thing called accidental languages, which is, there's all these semantics in this operation that we've described. This is what you'd call like an optimization language, or whatever you really want to call it. It's a language and it exists within the context of these functions, where friend link, that's not really a table name. It's not referencing any specific thing. It's like, we made this thing called friend link, and that's what we use. It's a token in this language. It's what we use to know that we have already joined one of these things, right? And so if you were to come in and just change one of these things, you're not just renaming something. You have to know if you change it every other place. Like it's an accidental language that is emerged while attempting to build an optimization system. And this happens all the time throughout our applications. So again, we're only covering the problems right now, not so much solutions. So let's talk about extensibility. Let's say that you have your accounts context. Whenever something happens with a user, you need to send out an analytics event to some sales platform. This is a really common request that we get, especially for user activities. Like, hey, every time a user signs up, send it to our data analytics tool or whatever. So how would you do that for all three of these functions? Like you need to make sure that all three of them get their data sent to an analytics tool. In this design, you have to, like, if this is what you're working with, this is the basic Phoenix generator stuff, you have to add code to all of these. There's no other way to do it. You can maybe, I guess, if you really wanted to, you could override your repo functions. It's a horrible idea. Don't do that. So if you're not going to do that, you're going to have to put functions in all of these code. And you might put a generic function like send analytics event. That way you don't have to keep modifying these functions, but you do still need to modify every single one of them. And so a lot of times when we're building applications, we have cross-cutting concerns that we need to put into the various operations. And if you can't do that, you're going to end up at a point where all of these functions just grow. They grow and grow and grow. They contain duplicated logic, and it makes things very error prone when it comes time to change how these things work. Because, well, do we change everywhere? Do we make all the same changes? Or, and if you don't want to have to touch every operation in your system to make a change. So move on to the next one. We'll talk about single use functions. This is one that's really interesting, which is functions are by nature kind of single use, especially in a language like Elixir where everything's immutable, right? It's like, it's not pure necessarily because they can still have side effects, but it's just a function. You can't really tap into it and translate it, do anything weird with it, right? So full name takes the user, returns first name and the last name, which I always like to point this out. It's not how names work in real life. This is just a useful example of calculated properties. Okay. So, first name, last name is not a thing everywhere. Actually, Kip Cole gave a really good talk about that recently, about what's in a name and how complicated all of that actually is. But let's say we want to do this in SQL, right? Like we have this same operation. This is the same thing. Like this is a proliferation of concerns, which is you now have to have the SQL version of what it means to get a full name and an Elixir version of what it means to get a full name. And if you change one, you have to change the other. If you decide that full name in your application is actually flipped and last name comes first, and you forget to change this, then your search doesn't work anymore. So at least it doesn't look like it works from the user on the UI because they're typing last name first and things aren't coming through. So these single use functions can be a significant limiting factor if we design our application in terms of functions. And you can make this a little bit better. You can like give them the same name, like instead of having this hang out anonymously in the query. I should have replaced this with the, calling full name. But that does communicate what you're doing, right? Like that this is a full name that I'm making inside of this query. It does not solve the problem of having to change both of these in lockstep. So limited composability. If we go back to our examples of joins, right? Let's say we have this current thing. The front page is tweets that are for the active user and they're from friends of the current user. But what if I want to use that differently? I don't want to and them together. Well, either they're for an active user or they're from my friends, which maybe is a weird filter to try to do, but these kinds of things happen all the time. Let's say to solve for this, we make an or for friends of, which uses or where. If we go back, instead of the where that we have here, where we say, where's it, where friend link or where user? Yeah, where friend link. So can anyone spot the bug that is with this code? I mean, there might be a couple bugs as was pointed out last time I asked this question, but there is an important bug. Go ahead, Jason.
If you compose this, then the or will create a bit of a mess in my experience. If you have another condition beyond this, you're going to get some unwanted behavior. That's at least my presumption.
Yes, that is the second issue, or that is a significant issue. It's not really the one I was getting at, but it is also, it's a similar problem that is also solved by the solution I'll show you later. But there's one more issue specifically around this join friend links, which is probably kind of what you're getting at as well, which is this join friend links is a inner join. Oh, here it is. Yeah, query join users, right? And so what this means is
people with no friends are going to disappear.
Exactly. People with no friends will disappear. And so you think you can compose this by modifying the or where, but you've given me this instruction. This is imperative code. You said also inner join to users, and you have to modify that behavior. Now you need to left join to users. And this also incurs a lot of the issues that you were just talking about, which is, well, now that we're left joining in multiple places, we're going to get expanding joins. We're going to get duplicate rows. We got all this sort of things that come from us trying to compose these relatively simple concepts. So that's where Ash comes in, and this is the nature of a lot of the problems that we've been attempting to solve. So I'm going to go back through. I'm not going to deep dive into exactly how Ash works or how you would use it. We have guides. There's all sorts of things you can read, but I'm going to talk about how we address these problems in Ash Framework. So these are our computed properties example where order matters. In Ash, the order is inferred. You don't tell us the order that the computation needs to happen in. You tell us when you build a calculation, you express the dependencies. Like some computed field says, I need some computed field 1, and we solve the order. We fill in the values, and we call your calculation module or your defined calculation in the appropriate order. So now if you go change the name of one of these things, or if you're whatever, right, you're not going to. If you reorder these in some way, I mean, it's kind of meaningless to do that, but that's the important thing, is that like we've removed this artificial thing that you have to do one before the other. So simple or optimize, going back to that example, is we can make it simple and optimize with a smarter tool. So going back to our calculations example, in Ash, when you build filters, you do not do explicit joins. So you don't say join to users or join to whatever. You give us what you call like a truth statement or like a logical statement about the user. So in this one, it's like, this tweet is for an active user when user.active is true. And internally, we're going to figure out what joins are required when we actually have to run these, when we have to put these into the data layer. And this from friend is a good example. We say, okay, well, it's from a friend when user.friendlinks.friend ID is my ID, right? So when this person is linked to me as a friend, then it is from a friend of mine. And when you use these in a filter, you reference these calculations. And if you're familiar with maybe something like Rails, where you might have used like scopes or something like that, this is actually more granular. These are not where clauses. These are calculations. They're segments of an expression that are reusable. So yeah, if I wanted to get the front page, I say for active user and from friend, and the data layer figures out how to join to satisfy this truth statement. And that's really important, because if I change and to or, you will get the results that you expect to get. We are aware that when we do analysis of the query that we're about to run, we're aware that in this case, the one that you're looking at on the screen here, that we can do an inner join because of the way that the conditions work, and that we're doing an and across this. If you change it to or, it's going to know that it has to do a left join, and it's going to know that perhaps it has to add a distinct, depending on the filter statement that you're using, in order to ensure that you don't get duplicate results. All these sorts of things are just solved for you under the hood. And for you, you get these nice, simple truth statements that you can use throughout your application. And yeah, this only joins to users once, because you're not telling it how and when to join. You're giving it a truth statement to satisfy. So we can talk about this accidental languages bit. I think it's kind of important to understand that the problem isn't the languages. I think, in fact, we often do less internal language design than we should. Our domains have languages. We use them every day with our stakeholders and with our fellow engineers and all that sort of thing. The problem I have is with the accidental, right? Which is when they just emerge accidentally, become very difficult to reason about. They weren't designed. And so in Ash, we look for designed languages. And these calculations are an example of a designed language, which is you now have this token for active user that was explicitly stated. You can see kind of where this lives in a resource, right? But we use this instead of the idea of like having to build these accidental or these emergent systems for optimization. And instead it's all declared what we have available to us, in our expressions and that sort of thing. And this goes a lot further. The rabbit hole continues on designed languages. There's a lot of Ash features around this area, but for now, we'll stick with the example you've seen. So let's talk about close to extensibility. In the example we showed originally with our sort of regular context with our functions, when not being able to add cross-cutting concerns without modifying every operation. In Ash, because all of these operations are modeled as data, we can do, more interesting manipulation of those things. So you might have a create action, an update action, and a destroy action. And in those, you can have what we call a change, which I'm not going to get too far into right now, but this change is it's like a plug, but for a change set. This module is going to take a change set and return a change set. And you can apply that to all actions. So now introducing cross-cutting concerns to the operations in your resource is as simple as adding to this block down here. Now, it's been pointed out that this may not be the design pattern that you want. Like maybe this is separating for you like the side effects of your system from and so maybe what you actually want to do is put that change in every single module or in every single action so that it's clear to readers, right? And that's perfectly acceptable. However, what I think is really important is that you've decoupled that choice from the technology behind it, right? So if you want to put it down here so that it applies to all of your actions, and you can move this line of code right down here. And if you want to put it into each individual action, then just copy that line of code into each action, right? So you don't have to couple the sort of choice of where the definition of that lives with how it's actually used. And I think that's very important. There's no implementation changes really needed. Single use functions. So this is going back to our full name example, right? In Ash, we have portable components. So full name is a calculation that says, first name plus an empty string plus last name. And you can use this in a filter, and that's going to get you a SQL query that got that expression translated into SQL. Or you can just ask us to calculate the value in memory. And this is extremely powerful. It's like you don't need the SQL version and the non-SQL version. We provide a expression syntax that covers both. And that's really powerful. So we go back to our example where you don't have to define both of these. And you see how this where full name equals, you don't have to define the structure around how to integrate it into a query or anything like that. But now you can say full name contains or full, like it's an extremely powerful concept to have these data layer agnostic expressions. This kind of ties into this limited composability that we talked about. Like, how do we OR these together? And we saw some problems with those originally. But now let's talk about this composable by design, right? Which is these, I can say for the active user and from friends of, or I can say or from friend, or I can say if it's for an active user, then it should be from a friend. If it's not, then it should not be from a friend. So these compose in more than just and or, right? They can be used anywhere within an expression like this. And this will actually translate to a SQL query. This is a case statement that we build that uses all this stuff. So it's a very powerful system. And I think it's also important to see that these calculations should be used all over the place, right? So we can write a policy that uses these calculations where if it's for an active user, then you should only be allowed to see it if it's from a friend of yours. We can use it in atomic updates where we want to maybe set the status of a tweet to published if it's for an active user or pending if it's not. But I think this is an example of design something once and be able to reuse it and compose it throughout your application. And calculations are a great example of that. And we have more examples of that, but I think calculations are the best way to highlight that. So typically what I would have done here is I would have gone through like a wide array of features to try to say, like, look at all the cool things that Ash can do. But instead, and this is what I've kind of learning, is it's a little bit better actually to do a deep dive on one thing to really illustrate sort of the superpowers that emerge from the system. So let's talk about atomics and bulk actions, right? So this is an update action in Ash. We say, it sets the attribute published to true. And you might call it like this. You might say, make a change set for publish and then update it. And again, there's a lot more things worth learning here, but this is not the point of what we're talking about quite yet. But what if you want to publish many posts? So you have a list of posts, or you have a query that would return posts. So you say, I want to publish all of these, right? So we have to be able to turn this expression here, or this change into an expression. And that'll make a little bit more sense when you see kind of how it is structured. But to see how we do that, you have to see what this is. Surprise, it's data. Like everything in Ash, right? It's actually data, which is here's a change module and here's some inputs that are going to go to that change module. And with that, we can add additional callbacks. We say, well, here's how to perform the change, but here's how to do it atomically. And in this case, set attribute is very simple. So the atomic is just set the attribute to the value, but they can get a lot more complex. It's just not worth diving into the details of that here. And so what this means now is I can pass in a query like this post where the author ID is the current user's ID, and I can say bulk update, and we'll set the status equals published. And the point of that atomic callback that we were talking about is that it can be a lot more complex, like incrementing score by 1, for example. And we'll see some examples of this when we go a little bit deeper down the rabbit hole here. Validations can be atomic too. This is very important. Let's say, we have this game resource and we want to increment the score by 1. However, the score should always be less than 100, right? What we can do is we can call the atomic callback on the validation, and you'll get a query that looks something like this. I mean, this is simplified a bit, but we'd say, okay, set score to score plus 1. If score plus 1 is greater than 100, then there's an error. And we actually raise this from the database query. Like the database statement raises this error. Otherwise, set the score to score plus 1. This is really powerful. This gives you a way to enforce the invariance of your application without sacrificing the ability to do things sort of atomically, like in a single query, which is safe for concurrency and more performant. Authorization policies in Ash are always applied. And this is another reason that we have to have atomics designed the way that they are, which is, let's say you're only allowed to read a game if you're one of the players in the game. That's this policy. And then let's say you're only allowed to increment the score if you're not changing the score from 99 to 100, which is kind of silly. It actually just, duplicates this compare logic or something like that. But we can actually build that into a single query as well, which is, first, we'll apply the read policies when we're deciding what to update. So we'll make sure that we're only updating the things that you as the user can see. And this is actually configurable. You can say update everything, but if there is something in the query that was provided that the user can't see, then it should be a forbidden error. So there's modes here. But here we can apply the rules about updating in this case statement as well, which is, if the score is 99 and the new score would be 100, then it's a forbidden. Otherwise, we'll apply that validation error we discussed before. If the score plus 1 is greater than 100, then it's an invalid error. So you don't have to know how to do this kind of magical thing of how to write your policies such that they can be run in Elixir or they can be run in a database query or anything like that. The framework handles that for you, which is really powerful. It unlocks entirely new capabilities. So what that means is this simple statement, given a current user, increment the score of all of their games, is all of a sudden a safe operation in isolation, which is you're just applying the increment score operation, but all of the rules that you have are honored. That's very powerful and very useful. So I want to talk a little bit about state machine. This is a specific example, a sort of recent specific example, which is we have a tool called Ash State Machine. And the purpose of Ash State Machine is to give you some nice patterns around, building out state transitions and the logic by which like each record moves through states. So you might have a packages table that is just tracking delivery of packages. And this is, of course, quite simplified, but it might be that it starts off pending, and then you can use the confirm action to transition from pending to confirmed. And then you can use the arrived action to transition from confirmed to arrived, for example. And here's an example of what one of those actions might look like where we transition the state to pending. But how do we do this atomically? So one of the things that happened is in 2.0, we had Ash State Machine, and 3.0, we introduced these atomics, and users want to use these atomic features, but we hadn't updated transition state to be atomic yet. Now, this is, I think, quite interesting is, so I go back in and I update this to be atomic. I rewrite the transition state or I add this atomic callback, and we can build all of this sort of stuff in the query itself, which is we can check to see, is it a valid state at all? Does it have a matching state transition? And you don't need to know exactly how this atomic expression works, but ultimately, this all of a sudden means it's that your state machines that would typically have required doing things like in memory, like fetch the row, maybe lock the row, check this old state and the new state, and then do some logic to translate, okay, old state to new state, and then save the updating row. But with the atomic callback implemented, you can do bulk operations over your state machines in a single query. Like you can say, move everything to complete. And if there's anything in there that can't move to complete, you'll get an error. This is extremely powerful in the same way of what we were already talking about. And we actually had, one of our users comment about this. They were looking for the atomic behavior. And I was like, yeah, okay, that should be pretty easy for us to do. We implement this action atomic with just ecto, right? So with the design, it wouldn't have been worth it to do it in your own application. But because you have a tool like Ash, we can make these things more flexible, powerful concepts, and then everybody benefits from those things. And this gives you concurrency, safety of your state machines right out of the box, and it gives you the ability to do bulk operations on state machines. So yeah, it's a really powerful concept, and we get to this sort of magic world where this state machine can be done atomically, and it all just flows out from the design of atomics. So that's atomics and bulk actions. This is really the end of the first part of our talk. So I'm going to leave the floor open for questions if there are any about kind of maybe the stuff we talked about. You can also ask questions about Ash in general, although I will revisit some of the basic concepts here soon.
Yeah, for the state machine part, right? How does that work? Because I'm thinking, because I have a couple of projects where maybe the state's kind of known, but it has to be kind of more calculated, right? Like, I'm thinking, do I really need to like go through and make a calculation to make this thing work if I don't have like a specific status or state on some type of resource?
Are you kind of getting at the difference between like having a state that's like computed versus having a state that is like control flow, like where
Yeah,
you
maybe it's more
change
of a
the state?
control flow. Like, I need to go back and see how it's written up, but I think there's a way that we have like a contract that needs to be approved.
Mhm.
But if I remember correctly, I don't think we actually have a status on the contract itself. Because it's kind of like, well, if there's a request to be approved for this contract that's not been approved, it would be nice to do something. So, for instance, like what actually would need to happen is that as soon as it gets approved, I would need to generate a PDF and upload that to S3.
Mhm.
But like I said, I don't think we have a status on the contract itself. So it's kind of like a known but an unknown thing.
Yeah, I think it could be a really powerful idea to build out your state machine like that. And basically, you require the actions that go through the state machine. So, like for one individual person to sign, it's actually like goes through the state machine. So, you'd have a state machine called like, signed by participant or something, and or an action that has the options to go from, its current state to, complete or to like awaiting signatures. So basically, like each time somebody signs, it will, and then the last person signs, and then it goes to complete, right? And then you have that hook. You're in that action now where you can say, okay, well, if I just went to complete, then go do some side effect or something like that. And there are a lot of benefits here to like you can generate state machine charts like that would just save them as images next to the resource that has a state machine, which will give you like just a good kind of to a business person or maybe somebody new to the scene, kind of a visual representation of the possible flows between these states. So yeah, there's a couple benefits. I think like I wouldn't suggest that a state machine like this is always better than a derived state calculation. Like sometimes you don't need it, but when you do need it, it's good to have it sort of formalized as a tool as opposed to kind of everybody hacking their own things around a state attribute. We had a question in the chat. So Ash is not an alternative to Phoenix. And the reason for that, I mean, in some ways you use Ash where like it replaces some parts of Phoenix. Like there's things that Phoenix did that you don't need to use anymore. And if you use our extensions like Ash JSON API and Ash GraphQL, you don't have to write your own controllers, for instance, or your own absinthe code or something like that. But in general, almost everybody who's using Ash is using Phoenix also. They're just two different frameworks for doing two different things. Phoenix is a web framework and Ash is an application. Gabriel.
Yeah. Yeah, I have a question. Like it seems like a very different way of writing, that maybe everyone's used to writing their Elixir code. I'm curious, is this something that you'd recommend you start, from a new project, or is it something you can add to, something you've already been working on for years? Can we put it in incrementally, or what are your thoughts on
Yeah.
on
Okay. I have a couple thoughts on that. The first one is you don't ever adopt a tool just because it sounds cool or anything like that, right? So like if your app's working, don't mess with it, right? Like a lot of times the cost of doing some sort of transition like that will not be worth the benefit. However, if there are pain points that you're dealing with in an older application that adopting Ash can potentially help with, then there are absolutely ways to go about doing that. And the most important thing to realize there is that Ash doesn't like take over your app. So like you can just add the Ash dependency, define a couple Ash resources, and they'll work simultaneously with whatever other code you have. So a lot of times people will take a strategy like that where they'll pick some small vertical slice of their application, like I don't know, like the PDF processing page, and like they'll rewrite those to be Ash resources, and they'll sort of start replacing things in that way. And it doesn't matter if there's like other ecto schemas that use the same tables or whatever, right? Like everything kind of plays nicely on that front. What we've also seen folks do, we had one of our bigger users or like our users with a lot of resources. They have like 100 resources or something. What they did is they added a resource for all of their ecto schemas, and then they put all reads through the resources, but left all of the mutations through the old code. And then they one by one moved over like their, context.create what user into like a create action on the user resource and that sort of thing. So there are definitely ways to migrate to, or even just not migrate, like maybe just pick the one part of your app that would benefit from the increased structure or tools. We found it can be kind of infectious, like not in a bad way. It's just hard. Like once you get all like you do get a lot of stuff just for free. And so it's kind of hard. You're like, man, if only this bit was in Ash, then I wouldn't have to be doing this crap. And so it is kind of an infectious design pattern, but that's not a bad thing really. It's just like, oh no, it's so useful that I want to use it everywhere, right? That's kind of the nature of it.
Yeah, I've been checking it out for a long time. Never tried it before, but I've always wanted to. Just never have the chance. Haven't had the time yet. But it seems I have to do it at some point. Yeah.
I wish you all the best of luck in being able to give it a shot. It's fun. I mean, Elixir's, even without it, I still would choose Elixir and the other tools that we have. So it's one of those things of like Ash is kind of like a cherry on top in a lot of ways. The ecosystem is already very good, which I think is a good problem to have, right?
Yeah. I have another question. I'm kind of curious about how it's built. It seems like it's a lot of macros. So you're just building like the AST, and then just at the very end, you're like running that to the database. Is that kind of
It's actually Ash. So the way it works is
got its own data structure?
There's a tool under the hood called Spark, which you can look at. It's deployed on Hex and all that, right? It's a DSL builder. So you define the structure and the structs that need to get built and all that sort of stuff. And then it defines the macros. And so it's really just a data structure. So there's like a struct called like, ash state machine dot resource dot transition. And this makes a list of like, there's a key called transitions, and it makes a list of these structs, right? So it's almost like a JSON or a YAML where it's like a nice way to declare structured data. This is like an Elixir native way to declare structured data that has benefits and useful features like setting defaults and transforming after the fact and doing all this sort of stuff. But ultimately, you just get a big data structure. There's one map that has all of this stuff in it. And that's what we use to do whatever we do. And we actually do very little code generation. So like there's a function somewhere like the logic to transition state. We don't generate a function or generate a whatever. We actually have a thing that just like checks the resource, and it's like uses that map of instructions, and it's like, okay, well, what are all the transitions, and what are the transitions before? What can it go to from this state? What can it go to this state, and all this sort of stuff. And that actually does make it a lot more easy to reason about. Like if you're like, hey, how does this work? You can pop into that function and say, okay, got it. So it's going to check this, generated code is much harder to reason about. And we only use generated code for very specific purposes. So like a good example of when we would use generated code is to check if a resource has an equivalent primary key to another resource. Like are these the same thing? If the types under the hood have a custom equality check, then you can't just say equals equals. And instead you have to like iterate over each one and check, does this key, and then use like ash.type.equal, that key and all that sort of stuff is very expensive, but it's also expensive to even check at runtime because, we stitch together records by primary key all the time. We need it. And so we have a function that we emit at compile time called like primary keys equal that has that knowledge embedded into it of like, well, are all the types simple equality? And if so, I can use equal. So that was maybe a little bit too deep down the rabbit hole, but we do use generated code for specific cases. Yeah. So talk about a bit about debugging in Ash. This is part of the trade-off. Like, I don't want to say that it's like hard to debug Ash, but it is harder to debug Ash than it is to debug a bunch of your own like written lines of code. And to some degree can only be solved so much. Like it will always be a little bit harder to figure out what's going wrong. But at the same time, there are certain things that Ash can do that will help you debug that you wouldn't get from your own code. So it's like a good example is when a policy fails, we log out a policy breakdown that shows you the workflow and where the policy checks were and what failed and how. And it's like that is only possible because it can be reverse engineered from your policies. And I would say that The same type of thing is true of a spreadsheet, which is maybe, you're using Google Sheets and you put something in and you get like not a number and you're like, how did I get this ridiculous value? And now you're kind of stuck tracing back through like, okay, well, go look at that field and go look at this one and trying things out. And in some cases, debugging Ash can be like that as well sometimes, which is you're like, okay, I need to go back and figure out what are the bits that led to this. But I would suggest like there are also entirely new and interesting and novel ways to debug these things that could be developed. Like just off the top of my head, you could click a button and you could get a little chart that shows you like the cell values that led in, right? I don't know why. I'm actually thinking about why don't they do that, right? Like, why can't I do that? I'm looking at a spreadsheet, just, make a little flow chart of the values that lead into this cell. And it's like that right there is a debugging superpower. So it's a lot of trade-offs in that front. And my suggestion would basically be that some things sometimes will be harder to debug, and it's kind of impossible to know what those things will be. But it's like, yeah, we take the control flow away. So sometimes you get a thing and you're like, I don't know. But other things are easier to debug because we have all this information and we'll present you with a report and a better concept of what went down and the breadcrumbs that led us to where we were. So yeah, I think it's a kind of mixed bag. It's a good question though. It's an important question also. So thank you. Okay, best way to navigate around using Ash. The documentation looks to still be under construction. Yeah, I mean, the documentation it's probably a never-ending project to some degree, but that's what I'm doing right now is a significant documentation overhaul that should be done within the next couple of weeks. That will be for Ash being deployed, before Ash 3.0 is deployed. And I would say right now we're still in a phase where, and maybe we never will go out of the phase, I don't know, but where the community is a significant asset, should be seen as a significant asset, right? So we have a Discord server, we're on the Elixir forum. And my suggestion would be like, don't be afraid to participate in that community and ask questions, and don't feel like you're imposing by asking questions, because it's quite the opposite. I was actually just talking to Alan about this, which is sometimes people will say, I tried to use Ash, but I couldn't figure out how to do X, Y, and Z, so I gave up. And I'm like, I'm available like 24/7 for questions. Like, so is the whole community is, right? There's like 25 different people who, if you had asked that question in our Discord server or an Elixir forum, they would have helped you. So my point there is just like, documentation is actually pretty good at this point. It's I would put it in a class of like decent, and we're going to make it good over the next couple of weeks. But the community is the real trick, which is that there's everybody who's built anything successful with Ash has done so with the help of the community around Ash, and then they give back into the community and they help other people. So real life examples in production. This is something. So the company that I work for, we're trying to work on like case studies and things like that, because we use it in production all the time. It's just the problem is there's not as much time to write case studies as there is to build applications, right? Like that's what the clients are paying us for, and getting a case study out of that situation can be difficult. So we do have tons of applications in production, and we do have example applications. Oh, sorry, my cat is standing in front of my screen. We do have some example applications like Ash HQ. Our documentation site is actually written with Ash. There's documentation search functionality that uses like Ash actions under the hood and that kind of thing. And we do have a lot of example applications. There's one called Real World, which is probably our biggest one. Yeah, so there's some examples out there, but that's the thing we need to work on, is like really illustrating that social proof, because I think we have like probably well over 100 applications in production with Ash, with plenty of real customers. It's just a matter of getting people to talk about it is surprisingly difficult in my experience. So Tony 3333, I'm curious about the question. Isn't YECC and aren't those like YAML parsers, or am I getting that mixed up? Is that like some sort of policy language? What is YECC?
Yak.
Yeah.
That's basically an Erlang version of Yak.
Oh, I see.
Well, you write a generation file describing your grammar in and with an Erlang syntax, and it converts to Erlang code to do that policy. And that's, for example, how Erlang.
Gotcha. That's actually an early trade-off we made with the DSLs themselves, which is that they could have been a parsed AST. And I see now what you mean. Like, basically, could we use a fully custom parser to do this, as opposed to, but like what we do now instead is like, if I go back to the policy example, is like, there's a macro called policies, and a macro called policy, and a macro called authorize if, and so on and so forth. There are benefits to doing that. You can do things like write Elixir in, right? Like you can use a module attribute Or you could say like, I don't know, call like if the timeout is greater than timer.seconds, 10. Like basically we would have to figure out how to take and then reevaluate any valid Elixir subset of the syntax. So what we ultimately opted for is that macros are kind of the trick for doing that sort of thing, is that if you make a macro, you can make essentially a sort of syntax token that does whatever you want without sacrificing the ability to support regular old Elixir. And so that's kind of why it looks this way.
Just one comment, leaks, that's a tokenizer. But again, it's the same thing. It's you're going to write a generator generating tokens.
I mean, that makes sense, yeah. And we did consider that early on. It's just
the rip-off from Lex and Yek, right? That's why. Hence the name.
Clever. Do we have any more questions? I do have some more content that I can go through as well.
Mine is related to the issue I was talking about in Discord the other day. I'm still thinking about this in my mind about, you do have this really awesome kind of pub/sub stuff built into Ash, which we didn't go over yet. But since you're asking my questions, I mean, this is my question right now.
Yeah.
So what's really cool about the pub/sub is that you can include data, right? So like, to give you a real life use case, I have like a prospect and I'm going to be sending them emails, and I want to actually hold on to the different events, such as an open email, an email that's been interacted with, like a click event, something like that. And every time an event comes in, I save that, and I would like to have a pub/sub that sends an update over a specific channel, right? So like I join a channel for every single prospect. So that way I'm only updating one prospect rather than updating like all like 20 or so I have on the page. Because I would like to show that, maybe the status of this prospect has gone from email sent to now email opened and then finally email interacted with. So basically that's 3 levels, that's 3 levels in total, right? You got the prospect, the email, and then finally the event, right? So upon event creation, I want that to trigger only a specific prospect to be told that, oh, it's time for you to update because something happened. That part I'm unable to figure out.
So I think kind of what you need is that, like, given just the leaf resource, you don't have the field for the root resource or something like that to say like this thing's ID is what's been updated. And so I'm assuming like right now you're just like reloading everything or something when.
For now, that's what I'm doing, but obviously I wouldn't want to. I want to say this particular guy, just reload him. That's what I would love to do.
Yeah. So let's just say I had an example of like, this is on event and there's like 2 more resources like organization and team, right? So like team, belongs to organization. This is just pseudocode, everybody. It's not what it actually looks like. And, organization has many teams. And then this is what it actually looks like, belongs to team. And so I could then do something like this. I could add an aggregate would use a first aggregate, call it like organization ID. And it gets the team's organization ID. So now I have a computed property on event called organization ID that maps to the containing organization ID. And then you have to do a little bit of setup to do this. And this is actually on our roadmap to make this not necessary. But in order to get this organization ID value, you have to make sure that it is always loaded on all of your change actions. So what we'd like to do is make the pub/sub notifier smart enough to load what it needs. But for right now, you can't do that. And then let me double check what the syntax is for this, because it's been a while since I wrote the pub/sub notifier stuff. Yeah. So you would say something like this. You would say like, publish, let's say you had your actions. Actually, you might even say publish all update actions or something like that. And then you'd say it's the organization ID. And then, you see you have like prefix. Actually, maybe you wouldn't use a prefix. It doesn't really matter, but we call it like event, for organization ID, something like this, right? So then basically whenever you did one of these update actions, again, lots of pseudocode in here, but you would then see you'd get a message like this: event, for org. Oh yeah, I'd probably do something like this: updated, right? So like org ID updated. So then you could subscribe to this and do something different to like render only that thing, or the subscription will have the change set in it. Right. So you could even theoretically, if you wanted to just like dynamically change it in memory according to something that happened and not refetch from the database, you can do that. Like you'll get a notification, an ash.notifier.notification, I believe,
Okay.
that has the change set and the new data and all that sort of stuff. So this is the general structure here, which is like you can use derived fields to link to things that are like, far away from the resource if you have to, and to use those in the templates for your pub sub messages. And then you can subscribe to, like, on your parent page, you'd subscribe to like the various, you might have like team for org updated or something like that. And you can make these the same if you want. You could just call this like organization updated, you could also do this and make it look like it came from the organization resource if you wanted, right? But that's kind of neither here nor there. Yeah, that's the general structure.
Okay, that's actually pretty straightforward once I knew about the load and doing the aggregate. Okay.
Mhm.
One more question too about like the 3.0, because I've been playing around with it. It seems pretty stable. Do you think it's okay to start to use in production now? And I know that there's still some support modules or libraries that are not yet updated, I'm guessing, right?
I think
It's
everything
from the
is.
table.
All of
Okay.
ours are. There are community libraries if you're using that I can't decide when those things are upgraded. But here's the thing. Officially speaking, like, we haven't put our clients on 3.0 because it is still technically a release candidate. And as technically a release candidate, right, we don't want to necessarily subject anybody to unnecessary issues. With that said, multiple people on the core team are running their applications in production with 3.0. So take that or leave it. Like, it is still technically a release candidate. So I'm not going to say you should just use it in production, but you will probably be fine. You will almost certainly be fine. And it is working as intended, and it is stable. Like, we will not be introducing any additional breaking changes in the release candidates. So yeah. Okay. We have two sort of additional segments that we can go through, which is resource overview, to talk about the basics of a resource. I'm kind of thinking maybe we'll skip this because you can read our getting started guide or read our documentation, and you can understand exactly how resources work. And I think maybe it will be better to just go to our community update, or our sort of, past, present, future. Okay, come on. There we go. Past, present, future stuff that I think are worth covering. This is kind of a good idea to see like what we're really working on. Oh, particular date for the 3.0 official release, early May. No particular date, but we're targeting early May, maybe mid-May. It really depends on how long a couple things take, but it's primarily documentation work, so it'll be soon. Yeah, 1.0 was an accident. Many people have heard that story. I've given that story on, I don't know, like 3 podcasts and 2 conference talks, so I'll let you hunt it down, but 1.0 was an accident. Okay, 2.0. 2.0, we've introduced a lot of quality of life things that were, or not so much quality of life, but I would say like a lot of what I felt was table stakes to some degree for a tool like Ash, right? Which is these really big core functionality pieces. And we've sort of wrapped those up to some degree. And that's why we're moving on to 3.0. So new types is a way to define like, derivative types. So you might have like a new type called phone number that is like a string that matches with a regex on, the string, right? So that's a new type. Open API, we want to be able to derive Open API specifications, and we do that now if you're using Ash JSON API. We have Oban plugins, Ash Oban, which is really great for automating your resources. State machines, which we showed you a little bit about how those work. Complex calculation composition, that's very heady concept, and there's a slide on it in a minute, but it was really important that our calculation system be rich, consistent, and performant. And we've made some significant changes to that underlying system, some of which have shown something like a 500x performance improvement over the last iteration. I don't like to say it, but not because the new stuff is blazing fast, but because the old stuff was really slow. But now it's not really noticeable. You won't notice any significant cost to using calculations. Whereas for a while, it was just the internal solver was quite slow. Anonymous aggregates are a big one that are very useful for writing complex calculations. Bulk operations and atomics were the big sort of targets for 2.0, which is basically, like we showed, the ability to take an action written for a singular, like in the singular case, like given some post updated in this way, and to be able to sort of automatically, maybe with some exceptions, but to automatically translate to a bulk operation while still retaining all of your validation semantics, all of your authorization semantics, and that sort of thing. And atomics are part of that. Atomics are the root of that, which is the ability to set resource attributes to expressions. So basically, like set score equal to score plus one. And that system has to be rich and support everything in order for bulk operations to work the way that we want them to. We've also grown the core team. So we've got James Harton. He joined quite a while now at this point, and Josh as well. Barnabas, he joined the core team last year, and he spoke at ElixirConf EU. Robert Graff is one of our newer additions, been doing a lot of great work with Papertrail. He's been busy for a while because he's doing the most important thing that anybody can do as a user of Ash or anything like it, which is build a business or succeed on your personal projects. I've talked about this a lot of times, but I would much rather hear about how your business is going well than get a pull request, because that's what draws people to use our technology, is when they succeed in their goals. But we also do have a potential announcement happening soon as for another member. Growing the ecosystem. So we talked a little bit about some of these, like Spark is our DSL building tool. Ash Authentication is the sort of plug and play authentication, sort of like our answer to Phoenix Gen Auth, because I don't like generating code like that. Ash State Machine, Ash Oban, we talked a little bit about. Reactor is a core piece, similar to how Spark was originally a part of Ash that we moved out. Reactor was originally something called Ash.flow that we essentially reimagined and moved out of the core. This is James Harton, his brainchild on that front, which is a graph-based Saga orchestrator. So basically, think of it like GitHub Actions type thing, where you define the dependencies between your various steps, and it solves it for you, and it supports rollback and compensations and all this sort of stuff. And we've also we've seen a lot of folks using Ash for financial applications. And one of the things we want to do with Ash in the long run is have higher level abstractions than just the basic resources. And so we have Ash Double Entry and Ash Money, which are packages that basically give you a sort of plug and play, but still deeply customizable double entry system built from your own resources. Super powerful stuff. And to go through some of the highlights here, right? Like, this is the open API stuff. Given this very simple declaration that just builds routes to your resource actions, you can just get a open API specification for free. It takes a couple lines to set this up once, and then all of your documentation, all of your descriptions for your various things flow through to your open API specification. State Machine is kind of the same thing. Rich calculation composability. So this is like, basically, you need to be able to arbitrarily deep refer to calculations and to refer to calculations anywhere in an expression. And now that is supported, which is you could have calculation references, a calculation references, a calculation, and goes through everything. Atomic updates, we talked about this already, but the ability to set an attribute to some expression, some derived value that will happen in the data layer. Bulk actions, like this is an example of a bulk create that lets you can use Elixir's fancy stream API to, bulk import. This is like a web scraper in very few lines of code, like fetch a URL and insert a bunch of data into the database, or maybe like an API scraper, not a web scraper. Bulk updates and destroys. So this is an example of a bulk update from our tests, which is we can bulk create, we can say return a stream of everything, and then we can map over that and update all of them. And this is a really extremely rich and flexible API that can be used to write things like importers and ETL tools and all sorts of fancy stuff. So talking about 3.0, we're shifting focus to developer experience, generators, we're working on a cookbook, best practices, all this sort of stuff. Like, I'm comfortable with where the base functionality of the framework is now, and it's time to spend more time on, removing sharp edges, increasing quality of life things, making it easier to debug, all these things like that. That's not the only thing we're going to be doing for 3.0. There's going to be plenty of features, but that is what we will be focusing on. Oh, debuggability. Yep. Okay, so that's all of the slides that I have. I do have a question here about walking through Ash HQ. Would you like to see the code or the app, like the usage of the app itself? Yeah. Okay, that does make sense. Yeah. Sure. Let me go ahead and let me pull it up. So we've actually simplified Ash HQ a lot from what it originally was. We always wanted it to be this sort of this like example application, but what we've sort of realized is it also is a real application with real needs, and it's kind of like you probably shouldn't conflate the two. And so we've decided like, okay, we're going to look into building new example applications. So, it's a basic marketing site in some ways. Like this is all written with live view, but this is all just, UI code. Except, I mean, this is a good example. We do a periodic import of GitHub contributors from all of our projects. So this number is always up to date. And then we have some features around documentation. So this is all imported from Hex so that it's also always up to date. We have a blog. This is actually written with a data layer I wrote for this purpose called Ash Blog. So there's quite a few things going on, but then we also have a search. So if I wanted to say like search for the word attribute, and then I click on this and it's going to take me over to the hex docs. So this is basically solving a problem that we don't have cross-package search for Ash packages. So this searches all of the core packages. So to show you what that looks like, I'll pull up the code. I'll show you some interesting bits of code. A good one to start with would be the GitHub stuff. So this is a quite simple. We have a domain for GitHub, which just has one resource called a contributor. And the contributor resource is basically like the login, avatar URL, HTML URL, and like the order that they contributed in. And we use this to power that list of images and stuff on the front page. And we also use Ash Oban to have a scheduled action. So we have this action called import, which is when you see this word action in the actions block, that's what's called a generic action. And it's just basically do anything. So this is an action that returns an atom and does whatever it wants. So it's, basically you could write it like this, but the benefit is basically we have type information about the return value. And if you had arguments, you could declare them as arguments. So if you wanted to put this up over an API or something like that, you would be able to do that. And then additionally, policies are applied for generic actions as well. So there are compelling reasons still to use generic actions, even when it could just be a function. Oh, and this is a good one, which is when you use a generic action, you can use it with scheduled actions for Ash Oban. So basically, every 6 hours, we're going to import all of this information. And then we call this run function in here, where here I go over all of the libraries that we have, and we go hit the API, the GitHub API, we pull out some data and we insert it. And we use, hash.bulk create with an upsert, which basically, create or update the contributor. So that way, if somebody changes their avatar URL or something, we get the update. And this is pretty simple. I mean, this is actually all of the code that runs that, which, is kind of a nice little example, which is you don't need much to get a lot done. So, and then, yeah, we also have like our docs API. This is a lot more in depth. This has, like we have libraries, and you can see like there's a lot of different actions that you can do on libraries. We also have importing, so that we import libraries from hex docs, and we even have we have caching on libraries, because libraries is like a very low cardinality resource where it's like the list of core libraries changes almost never. And so what we do is we store the data in an agent, and then if we get it, we use ash.query.setResult, which basically says you don't need to run the query. This is the result of the query. And so we can use that in a hook to sort of replace the implementation. It's one way. There's other ways. You can make a manual read action, but the reason we do it with this way is because if we don't call set result, we want you to do your regular read action. So that's why this is kind of the right pattern here. And yeah, then we have, search is actually implemented with Haystack, which is basically we switched off of doing Postgres full text search because it was just a little janky. And this was, simple and easy to set up. And so at the beginning of the app, we just, when we start up, and every some number of hours, we index for search. Okay, so do we have any questions about some of the stuff I was talking about on the application side with Ash HQ? Or questions about really whatever?
I'd like to kind of get an idea about how difficult it is to actually create my own extensions, right? Because
Yeah.
some of them are really, really nice, but reading kind of Spark, I guess if you work with it day in, day out, it starts to make more sense. But I was trying to diagnose why this thing wasn't working, and I tried reading Spark, but it's an acquired taste, I guess you could say.
Yeah, I'll tell you what. Let me just make sure that nothing's blowing up. Okay, things look good. All right. So let's just make one. We'll make a soft delete extension. It's quite simple. I would agree that it is quite simple when you know how to do it, and that is important, right? Like the problem is basically Spark hasn't been fully documented yet because it was extracted out of Ash and is primarily used by Ash. And there are other people using Spark, like I forget his name in real life, but Dorgan, from Sorcerer and stuff like that, uses Spark for a thing called Channel Handler. There's people using them for using Spark for various other things, like completely unrelated to Ash. So call it. This is just an example application. So we might say, use a Spark DSL extension, and then let's give it a DSL. We're just going to call it. So then we say spark.dsl.section name soft delete. And then we'll give it like a doc, like configure soft deletion for a resource. And then we'll say sections soft delete. So this is actually the way that you introduce custom DSLs when writing custom extensions. And I will say, like, this is one of the major superpowers. What doesn't it like this? At doc not found. Oh, I think it's describe, actually. Sorry. One of the major superpowers when using Ash is ultimately when you get to the level of proficiency that you're writing your own extensions, because it's a really powerful thing, but it's never necessary to write an extension. Like, extensions are basically ways to compose the things that you might do by hand otherwise. So you don't have to learn how to do this anytime soon, but once you do, it's quite powerful. So let's go ahead and give it a schema, and we'll say Zed editor sometimes. Or maybe that's not Zed, maybe that's Elixir LS. Anyway, we'll give it a schema for options, and we'll say, like, actions or only actions, which is a list of atoms, or we'll just call it actions. A list of atoms. And we'll give that a doc, which actions to do soft deletion on. So now if I were to go to tweet in here and I were to say, modify the extensions list, I could say, hash or twitter.extensions.soft delete. And then I would should be showing me this here, but it might just be the language server being kind of rude sometimes. Anyway, you can then do this, and you can say, like, actions destroy, right? So soft delete for the destroy action. And then typically what you would do is you would make an info module. And there's actually a cool thing called info generator. And then I can say sections, I believe, soft delete. Let me double check how we do this. Yeah. So we'd say extensions, twitter.extensions.soft delete, and then sections, soft delete. And yeah, so now if I go in here and I say start up my app, extension not found in, what did I do? Did you mean extensions? Ah. Okay. access.get soft delete info, soft delete, name, soft delete, sections. List atom, that's right. this is going to be in my type definition. That's right, because that's not how this works. You say type doc, looks like that. So now if I go, I have my tweet resource and I can say soft Twitter dot extensions dot soft delete dot info dot soft delete actions, then pass in my resource, and it says, hey, it's destroyed. And actually, this is a good example of to show you how the DSL is just building a data structure. Is if I say dot spark DSL config, I get a big old map of all of the stuff. So these are all the policies, and these are all of the the whatnot. And here's the JSON API routes and GraphQL queries, the code interface. All of this is just a big data structure that's stored in the module. And soft delete is there as well. Yeah, I mean, in my experience, Z is just, to my quick 10-second answer, Z is just more convenient. It does less, but it breaks less. And I have way too much to do to screw with an editor these days. 5 years ago, I would have spent hours a day screwing with Emacs or Vim. I loved it. Don't have time for that kind of thing. Okay, so this doesn't do anything aside store some configuration. So to show you where the real sort of power is, we're going to add some transformers. We'll call this, mark actions soft. We'll call it, let's see, we'll just call it setup soft delete. So make a transformer, and we'll define our transform function. And right now we're just going to return. So this gets that big map I showed you before when you called like .spark DSL config. And then what I can do is I can do this. I can say, first, we'll use ash.resource.builder.add new attribute archived at. It's a date time. We'll set actually no default, and it's not required. So we'll just do this. And then we can say, mark actions as soft. And say def. I think we do this with use spark.dsl.builder. Now I can say def builder. This will be called mark actions as soft. These are just conveniences. You really don't need to know how to do all this stuff out of the gate. But, so now we can say ash.resource.info.actions to get the actions off the DSL. And then we will, filter type equals destroy and name in we have our twitter.extensions.softdelete.info.softdelete actions. So you can see we can pass the module or a DSL map, and this will get us out the data that we need. So now I can reduce the DSL and then say action DSL. And then we can take this action and we can say mark it as soft. This is an Ash feature that we're just toggling on. And then we're going to add a change. And this will be like ash.resource.build action change. Actually, now that I think about it, there's a cleaner way to do this. I'm going to do that. Instead, we're going to say DSL ash.resource.info. No, we'll just say ash.resource.builder.add change. And then we will say add change. I need to remember what the syntax for this is, and my language server isn't helping me. Add change. Okay, so it takes the DSL builder, module. Okay, so then we'll say, twitter.extensions.softdelete dot changes dot soft delete. No options. And then we will say on destroy. All right. And actually, this is all we need. So I'm just going to do this right here. Don't need any of that stuff. All right. So now we can add the changes and we're going to be good to go. Soft delete. So we're going to check to see if the action name is in the configured soft delete actions for this resource that is being changed. If not, we're going to return change set. And if it is, we're going to say ash.changeset.force change attribute archived at datetime.etc now. So this is pretty simple what we're doing here. Basically, it's like if it's in the actions we care about, we know that the actions have already been marked soft. Oh, actually, yeah. Wait, I still need to do that part. And I removed that a second ago. Mark action soft. So let me just undo this actually and go pick that code back up because we still want this. It's just that the change is going to happen like this. So yeah, so we're going to go through each one of these and we're just going to mark it as soft true. Okay, so that causes it to be treated like an update instead of a destroy. So now mark action soft. Don't need this. Variable DSL is unused. That's new. This must be some weird thing with the def builder. I haven't had to build an extension in a long time, actually, even though I do it. Oh, well, that's not true. I haven't had to build an extension in front of people for a long time. 1 second. Let me see. DSL state. This is how we do it in real life. So let's see if it actually has a problem with this. Yeah, it doesn't like this. That's fine. I will do this. And this is just called DSL. DSL is unused right here. Enum.reduce. Right. Okay, so now replace entity takes more arguments than I gave it. Show me the docs. What are you doing? DSL state path. That's right. Okay. There we go. So now what we should see when I go and ask for the action I should get, it says soft false. So it's not picking up this change that we made. So let's make sure that we're actually getting into this code. Oh, yeah, we won't because then you have to do transformers. You specify the transformers here. Oh, and one other thing, the transformers all have like a sort of life cycle. So we're going to say that this runs after everything because reasons. Okay. Identifier not found in resource.actions.destroy. So this does happen. This is not a problem for new things, but for us, we're going to have to say action.name equals, let's see, existing action.name. We have to provide the replacer function. Cool. And so now we can see that we marked it as soft. And then if we ask for the changes on a resource, we get that there's this soft delete change on the resource. And if I were to say like, I haven't set up the database for this project yet. Okay, so come on. Oh, it says I have. Oh, right. We need to generate migrations. And I need to give it a name called add soft delete. Come on. And then we'll run migration. So this generated migration for the resources. This is another example where the integrated tool set actually helps a lot. So like in this example, the migration generator knows what the actual structure of the resource is. So even though there's a resource that's adding an attribute, I don't have to remember to go write that migration, right? It will generate it for me. But it's also not just magic, like it generated a regular ecto migration that you can look at. So it's kind of cutting that middle ground. Okay, so now I can get a tweet. Right, and then I can say, do I have a code interface function for this? Tweets. Yeah, I have delete tweet. Okay, so I'm gonna twitter.tweets.delete tweet. Okay, destroy must be performed atomically. That's fine. This is a helpful warning telling us that destroy couldn't be done atomically. If you write your stuff right, you won't have to do this. I'm just trying to save some time. So require atomic. Oh, destroy. It's not a read action, it's a destroy action. And we have no policy that's allowing us to do this. So I'm going to say authorize false. All right. And you can see now this update tweets, like instead of destroying, we update the tweet and we said it's archived at to right now. And I know it was fun. Maybe it was fun. I don't know, to see this extension written in front of you, but there already is one. It's called Ash Archival that does this, but it's a great simple example of an extension. And you can see from the resources perspective, all you have to do is include the extension and configure it. And then the extension is given the opportunity to transform the resource in some way, to extend it with maybe some capability or with some behavior. And this is exactly the same way that Ash Paper Trail works. It adds a change that hooks into every action that happens that will emit an audit trail for everything. And we do that kind of thing sort of all over the place. So yeah, an extension is basically a combination of a configuration and some transformers, typically. And it works. Okay. Any other questions?
It's a real quick question. You don't have to go through and do it, but I was curious. I mean, since you can do all this, now that you have the soft delete, then obviously you can somehow prepend a query saying, give me all these resources where they're not archived, right? You can just inject that using the Spark DSL or no?
Yeah. Okay. So it's complicated. You can't, it's not complicated. There's an option called base filter. And that's what Ash Archival does. A base filter is something that's applied to all actions everywhere on the resource. And so that's what Ash Archival does, is it adds the archived at field and it sets the base filter. So that way you never get archived at resources in your read queries. And the only problem, the reason I say it's complicated is because we want to figure out a good way to potentially allow like certain actions to bypass the base filter. people want to make like an action that returns the unarchived one or the archived ones so they can like revive them or something, right? And right now you have to make like a whole nother resource or something. Granted, it's really straightforward to just not use Ash archival and update your only a certain set of your read actions to have that filter. But so the point there is like, yes, you can do that. And we're kind of looking for how we should design it so that you can actually like bypass that for certain read actions. So probably what we'll do is not use a base filter. And instead we'll add a preparation to every read action except for ones that you specify. So it's basically like hide archive, or maybe an option called like show archive records in, and then you give us like a list of read actions, and then we won't filter in those actions. Actually, that is the answer. And I should just put that on my to-do list because we figured it out.
I find that a lot of times when I ask you a question, you talk like this, and it's like, oh yeah, actually that is the answer.
Yeah.
I guess this is your thought process.
Yeah, I'm very reactive. I'm very focused on what people need actively. And a lot of that involves not getting too tied to what I think needs to happen, and instead being focused on what I hear from the people around me, what our customers and users are saying. And so I just get pulled along by the nose, basically. I mean, I do have my own goals, but I see a lot of frameworks get kind of eaten away or obsessed with like their own goals and kind of forget to some degree what their users are actively needing at any given time. So I try to keep a good balance there. I think that's probably a good stopping point for me. I'm happy to answer some more question.
I mean, I have this kind of a quick question about it. I'm kind of curious because it's something I'm looking at is to use the tenancy for a project. How does that actually work? Because I saw some people, they want to use like schemas within Postgres to do this, but Ash doesn't do that. It wasn't entirely clear when I was looking at the documentation just quickly. Do you mind just very quick explain how it does it?
So you can do either one. Ash kind of abstracts the specific implementation. The way it works is Ash has one strategy built in, which is the attribute strategy. And then you can set the strategy to context, which means the data layer will provide the strategy. And in that case, Ash Postgres will use schemas. So you can use either one. You can mix and match too. In fact, like some cases, some folks will have like some resources that may need to be accessed across tenants will use attribute multi-tenancy, because then there's an option called global that you say global true, which means like it can be accessed without setting a tenant. So then you have some stuff in attribute multi-tenancy, some stuff in schema multi-tenancy, because it's like those two should never mix. Maybe there's something super secure and or whatever. But yeah, you can do both or either or.
I just did attribute multi-tenancy. It's probably harder than an Ash because you have to write rules in an authorizer that works very differently than your declarative model, but it's pretty nice even in Ecto. I think just some people are super nervous about writing multi-tenancy in Ecto without schemas because it's not hard to screw up scopes in Ecto. So I think that's like 90% of the reason why people end up using schema-based solutions in Ecto.
Yeah, so I mean, from what we've seen, lots of people use attribute multi-tenancy. You don't really need to do anything extra. It just works.
Yeah.
And it also does smart things like if you have like a unique constraint, if you use an index on the, we call them identities, I mean. If you add an identity for like two fields saying they're unique, the migration generator will like include the multi-tenancy attribute in identities by default. And if you have like foreign keys from one resource to another resource, it'll make them compound with the tenancy attribute and stuff like that. So it's quite smart. And I think the big thing is like, and that's actually a really good way to talk about it, is like people are afraid of making a mistake. And so they'll use schemas. And my goal is to like, a lot of the goal of Ash is to make it so you don't, like, we enforce multi-tenancy universally, like the same way you can't screw it up for either one, right? So now you get to make the choice based on purely the technical merits of the thing, which is like, do you need a schema of, because maybe you need it because it's huge data or something like that, and so you need to not, or you have GDPR co-location rules or something, I don't know, and so you have to have them in a different logical storage. But otherwise, it's like you're free to just choose attribute because it's more convenient.
Yeah, I mean, even in Ecto, I felt like as long as I made predictable patterns of use, it was not too bad. It just required more cognitive load than Ash's solution.
Yep. Yeah.
What about association? So, it gets kind of hairy if you have, nested associations, right? And in Ecto, I solve that by preloading an association. If I have, say, comments or something like that, and that's associated with a job. I don't want to put a tenant attribute on the comment. I just put it on the job. Does that work for multi-tenancy out of the box? Or is it a little complicated?
Kind of. I mean,
if you don't want to put it but it wasn't hard. It's just
yeah. I mean, it would be fine because if there is no attribute, like if there is no multi-tenancy, then the queries don't do anything with the tenant. So if you just have like a jobs table that is multi-tenant on attribute multi-tenancy and a comments that isn't, and as long as the foreign keys are set up right, then it'll just work because we won't set the prefix on, or we won't add the attribute filter on the one and we will on the other. And the same thing is true, but vice versa. Like if you query, let's say jobs is not multi-tenant and comments is, if you query jobs with a tenant, like nothing changes about the jobs resource because it doesn't have an attribute, doesn't use multi-tenancy, but the related things will use that tenant. So it is nice to have that mixed scenario, and we'll apply it just like to the places that it matters. And we still carry the context through. Even when a resource doesn't have multi-tenancy, we still carry it through in case some like nested association is also multi-tenant or something like that.
Oh, that's cool. My last company basically is wound down to a skeleton crew, and I just have a part-time consulting contract with them. But there were definitely a few bits of friction with the domain model around tenancy that we built that I think could have been cleanly handled by Ash.
Yeah, I would say the one thing I would like to introduce at some point, but I haven't, is the way strategies work are actually like those two strategies, and it's a little bit un-Ash-y in a way. They're not behaviors where you can implement one yourself. It's like you use attribute or you use context. And what I would like to do is you can put in a module and we'll ask your module and then refactor these other two to do the same sort of thing. I think that would be a more powerful concept, but at the time we didn't really know how it was going to shape up, and so I didn't know what the behavior was going to look like and stuff. But it's a pretty well set in stone pattern now, so I think we could definitely support even more interesting strategies. Like some folks want separate databases, even like a repo per tenant or something.
Yeah, I mean, I do that with the Elasticsearch, and what I was originally worried about in that case was, essentially shared resources in terms of provisioning, and there's a whole bunch of factory data that goes into Elastic that it's not impossible to solve with a single Elastic instance, but it just didn't seem worth it. So I just have separate Elastic instances per tenant. So I could see some cases where you might do that with Postgres, especially the GDPR case.
Cool. All right, everyone. Thanks for having me. I appreciate y'all sticking around. I'm around if you have questions or anything. You can find me online, and Alembic, my company, if you're interested in having any project work done, feel free to reach out. We do have an Ash Premium support. It's important to note it's separate from Ash itself, but Alembic offers an Ash Premium support package, which is essentially if you're working with Ash and you want a little bit of a head start, a little bit of guidance and PR review and architecture review, that kind of thing. It'd be really good choice.
Awesome. Yeah, again, thanks, Zach, for coming on and sharing so much with us, even building a mini extension that was more than I was expecting, but definitely useful to get to have an idea about that. Again, thanks for coming on, and thanks everybody for joining. I'll announce when the next meetup's coming, and if anybody wants to give a talk, let me know.